All right, so let me introduce you to the world of trigonometry. Today we're going to use SOHCAHTOA to help us solve for missing sides or missing angles. Today, missing sides. The next video will be about missing angles. We're going to use SOHCAHTOA to help us find missing sides of a right triangle. It's very important to note that this only works for right triangles. So here you can see I have a right triangle. The corner is 90 degrees. So I'm going to show you how to use SOHCAHTOA trigonometry to solve for missing sides of a right triangle. It's going to be a little bit maybe out of your comfort zone. SOHCAHTOA and trigonometry, pretty big word, it might scare you a little bit, but it's not too bad. It's something a little bit brand new, but it's not bad once you get the hang of it. So the first thing that you need to know how to do for SOHCAHTOA is how to label correctly the sides of a triangle. So looking at my right triangle here, you should already know which side is the hypotenuse. So this side here is my hypotenuse. We're going to label the two other sides. We're going to label one of them opposite, the other one adjacent. It depends on which angle we're working with. So one of the angles will be marked for you. Let's just start with the top one. Now we look at this angle and find the opposite side. So the opposite side, we would go out, and whatever side we run into, that is labeled opposite. Then that third side is adjacent. Adjacent because it's next to this angle here. Now, if we were to be dealing with the bottom right angle instead of this top angle, these two labels would switch. So let's suppose that I'm looking at this angle. Well, opposite would be this side, and adjacent would be down here at the bottom. Notice hypotenuse does not change. That is always the longest slanted side that's across from the 90-degree angle. That is always hypotenuse. Opposite and adjacent, it just depends on which angle you're looking at. So let me clear this really quick. So let's go back to working with, let's say we're working with this angle. This is always the hypotenuse. This side is opposite. We're just going to put an O. Then this side was adjacent, and we'll put an A. So that brings us to SOHCAHTOA. So, first of all, this S, C, and T stand for the three most common trig ratios. S stands for sine. C stands for cosine. And T stands for tangent. I've never heard of these words before, but they're commonly used in trigonometry. So going back to sine, we often write it as S-I-N, sin, we abbreviate it. And how we set up that ratio is sine of my angle. This symbol is theta, it means angle. It's almost like a cursive O. Equals, look at these two letters that are next to the S. You write it as a ratio, O over H, opposite over hypotenuse. So sine of my angle equals opposite over hypotenuse. And we will use that ratio to solve problems. Let's go to cosine. Cosine, we usually abbreviate it as COS, and you'll see that button on your calculator. Of my angle, remember this symbol means angle, equals what? Look at SOHCAHTOA. A over H. So very important trig ratio. And that brings me to tangent. Tangent is often written, abbreviated as tan, T-A-N, of an angle equals O over A. Oh, sorry, it's hard for me to, the bottom of my screen. All right, so let me clean that up for you a little bit. Okay, so if I go over to my triangle and I label it theta, it's just the symbol we use for an angle. Here are my trigonometric ratios that you need to have memorized. SOHCAHTOA, that's just a saying we use to help us memorize. Sine is opposite over hypotenuse. Cosine C is adjacent over hypotenuse. And then lastly, tangent TOA is opposite over adjacent. So say it with me, SOHCAHTOA. So we're going to use these to help us start solving for missing sides of triangles. So let's go ahead and start an example. So here's a right triangle, and we have to find this missing side at the bottom. So the angle is 43 degrees. One side is 12, the other side is x. So your first step, we're going to break this down into steps. Step 1 is to label these sides that are given. So here we have a side that's 12, here's a side that's x. We need to put labels on those. Is 12 a hypotenuse side, the opposite side, or adjacent side? Is x the hypotenuse, adjacent, or opposite? So looking at our angle 43, if we go across, we'll run into x. So x is opposite. I'm just going to write OPP. The long slanted side is the hypotenuse, which would be this side here, but that's not labeled, so we're not going to label it either, which means 12 would be the adjacent side, the side that's next to our angle. Write out SOHCAHTOA. That's your second step. And choose or TOA, there we go. Which of those three parts has an O and an A? That would be TOA, tangent. So we're going to use tangent to help solve our problem. Again, that's because our sides are the opposite side and the adjacent side, O and A. And tangent is the only one that includes the O and the A. So write out the tangent ratio. If you want to go back, right here is my tangent ratio. Tangent of my angle equals O over A. Tangent of my angle equals, remember this tells you, O over A. Then we start plugging in our information. So tangent of my angle. Well, I know my angle is 43 degrees. We put that in parentheses. Equals O, the O side or the opposite side is x, over A. My A or my adjacent side is 12. So that's how I plug into that ratio. Now to solve for x, it's just like solving an equation. To get x by itself, we want to undo this division, so we use multiplication. So multiply that right side by 12 and this left side by 12. Use a different color there. It's all kind of getting blurred together. So when I multiply this right side by 12, that means those 12s cancel. So I get x equals, I'm going to bring down this right side, this left side, 12 times tangent of 43 degrees Now I just put this in my calculator and I'm done. 12 times tangent of 43 degrees. So let me grab my calculator, a picture of it. Before we put this in our calculator, you need to look at your calculator and you need to find the mode button. When you hit the mode button, you need to make sure that the degrees is lit up and not radians, because we're dealing with degrees, 43 degrees. So if your calculator is in what's called radian mode, you're going to get the wrong answer. Okay, so once it's in degree mode, you're going to put in 12 times tangent parentheses 43. And right here is my tangent button. So put in 12 times tangent. It'll open up a parentheses for you. You just put in 43, close your parenthesis, and hit enter. And you should get 11, rounding to the nearest tenth is 11.2. That is the missing side of my triangle. All right, so maybe that felt a little bit crazy and overwhelming, but let's try a couple more. It'll get a lot easier as you go along. Right, number 2. So your first step is to label the sides that are given. So we have one side that's given as x, one side that's given as 12. 12 is my long slanted side, so right away you should label that as the hypotenuse. Now looking at my angle, going across from my angle, we run into the side that's labeled as x. So that is going to be my O side, or my opposite side. That bottom here would be adjacent, but since it's not labeled for us, we're not going to label it either. When we look at SOHCAHTOA, so your next step is to write out SOHCAHTOA. How we pick sine, cosine, or tangent is by looking at these labels. We just labeled our triangle. So we labeled H and O, hypotenuse and opposite. So looking at SOHCAHTOA, should see that first part, SOH, sine equals opposite over hypotenuse, so that matches up with our O and our H. So we're going to use sine. So we can go back to that first slide and look at sine, which is here. Sine of my angle equals O over H. So sine of my angle equals, again, this tells you O over H. That's why you need to memorize SOHCAHTOA. Right? Now just plug in sine of my angle is 21 degrees, equals O, which here is x, over h, here it's 12. So sine of 21 degrees equals x over 12. To solve for x, like before, we multiply by the bottom. The bottom is 12. Multiply both sides. What I do to one side of the equation, I have to do to the other. So here, my x's cancel. So, sorry, my 12's cancel. So x equals, and then just put this in your calculator and you'll have your answer. So you do 12 times sine. There should be an SIN button. It should be 2 buttons above 7 if that helps you find it on your calculator. Of 21 degrees, so put 21 in parentheses, and you should get 4.3. So that side here is 4.3 units in length. All right, let's do one more. All right, number 3. Here you can notice that we have two angles given to us. We have 28 and 62. So if that were the case, you just get to pick which angle that you want to work with. It really doesn't matter. It will affect which ratio, which trigonometric ratio we use, sine, cosine, or tangent, but it's just kind of your preference. So here I'm just going to pick 62 to work with. Again, it doesn't matter. You could have picked 28 to work with. It doesn't matter. Okay, so it does matter when we're setting up our sides. This x, that side, is going to be my hypotenuse side, because it's the long slanted side that's across from my 90-degree angle. Looking at this side 50, that is going to be adjacent. So hopefully you're getting the hang of labeling these sides. Adjacent, it's right alongside of your angle. If I looked at this side, that side would be considered opposite. Since that's blank, we're going to leave it blank. So then your next step is to write out SOHCAHTOA. And then choose which one includes an H and an A. So that should be CA right in the middle. Cosine includes an A and an H. So again, step 1, label your sides. Use those labels to choose sine, cosine, or tangent. Choose correctly. Okay, so then write out your ratio. Cosine of your angle, C stands for cosine, equals A over H. Then we plug in. My angle is 62 degrees. A side is 50. My H side is X. Okay, so just like the first two examples we did, our first step to solve this is going to be multiply both sides by X. This one's going to look a little differently. We want to get X out of the denominator. So we're left with X times cosine of 62 degrees equals 50. We're trying to get X by itself. Here we just moved X to the left side, which is fine. But to find the value of X, to undo this multiplication here, we're going to divide by cosine of 62 degrees. That cancels on the left side. So just bring down your X. Equals, and then just put this in your calculator. 50 divided by, hit your cosine button, and then type in 62. And you should get 106.5. So that is how you use your 3 trigonometric ratios to solve for missing sides of right triangles.